All right, so we have a definition. The definition is complex conjugate. Now, complex conjugate are two complex numbers of the form a plus bi and a minus bi. All right, now I'm going to show you this. All right, 2 plus 3i. Okay, that's a complex number. All right, what we term as a complex number. Reason being is it has two parts: a real part and an imaginary part. All right, everybody see that? You can't add them together because you can't combine like terms, right? Because you have an I in one and not an I in the other. So you're kind of stuck. So that's a complex number. Now, that conjugate of that number is a special relationship to 2 plus 3i. All right, so the conjugate now of 2 plus 3i is 2 minus 3i. Okay. 2 minus 3i. Okay, so for another example, let's say the number I gave you was 7 minus 6i. Bless you. What would its conjugate be? 7 minus 6i. Conjugate would be 7 plus 6i. What do you do? How do you get this conjugate? You change the sign in the... Starts with an M. Middle. You change the sign in the middle. That's it. Numbers stay the same. The sign of the first number stays the same. You change the sign in the middle. Okay? Now that bottom section here. The product of complex conjugates is always a real number. And that's where our problems are going to come into play. You can use this to help simplify the quotient of two complex numbers. Simple here. Now, let me explain what you want to get accomplished. Okay? What you want to get accomplished is you can't have i's in a denominator of a fraction. Okay? Because they represent square roots. And you can't have square roots in the denominators of fractions, so by extension you can't have i's there. So we need to multiply this fraction by something that is the same top and bottom, that when we do so, we're going to get rid of the I here. Okay? And I'm going to tell you what we're going to multiply by is I. Because what's I times I? I squared. And what's I squared? Negative 1. Look, gone. See how that works? I times I is I squared, and I squared is negative 1. Okay? Now, I can't just multiply it by I on the bottom. I also have to do what? You have to do I on top. You have to multiply by the same thing top and bottom. Okay? Everybody good? Nash? I'll show you. Let me walk through and I'll explain it, okay? All right. Now, when you multiply fractions, because that's what this is, right? In essence, it's just a fraction. You multiply what together and what together? You multiply the numerators and the denominators. Okay. So we're going to turn this. Into one fraction. All right. So 4 plus I, and we're going to multiply it by I. And then down below, we're going to do 5i times I, right? Just do the multiplication of what's over here. Everybody see that? What are we going to do up here? Starts with a D. Distribute. This is the funny part because it distributes backwards. Okay, but that's okay. Just distribute it. Okay, so 4i plus I squared over, and what's 5i times I? 5i squared. Okay? Now, we already said what's I squareds? -1. So now go through and make all your I squares -1, because chances are you will always have 2 of them. Okay, so 4i plus -1 over 5 times -1. Okay, finishing up right here. What's plus and negative become? Negative. So you have 4i minus 1. And what's 5 times -1? -5. For you guys, you're done. Okay. See how you moved the I from the denominator and got rid of it? Okay. And you did it with a beautiful process without making any silly boo-boos. Multiply it by I. Makes it I squared. And I squared is -1. Okay? Not bad. Did that help? Seeing it all. But even though for the second one here you have a binomial in your denominator, your goal stays the same. You need to get rid of the I. Okay? So let's do a couple crapshoot ideas. What do we want to do? What do you think? We'll take suggestions from the choir now. What do we do? Multiply by I. All right, let's give that a shot. Let's see how that goes. Keep your erasers handy. All right, if we're going to multiply by I, that means we're going to do 3 plus, whoops, come on, a little bigger. 3 plus 6i times I, and we distribute that I, that's going to give us 3 plus 6i squared. Oh, I missed an I, didn't I? It's going to give us 3i plus 6i squared, which will become minus 6. Okay, we got rid of the I off the 6, but do we still have an I in our denominator? Yeah. So did we make any progress? No. Hello, Mr. Eraser. And we try again. That's why you do pencil with math. Okay? So I doesn't work. What else we got?
Negative or 1.
Just 1? You want that to give us the same thing back?
No. Negative I.
Negative I. Well, looks like a stick man, but we'll roll with it. What's 3 times negative I? Is it gone? No. And back. So it's gone. -1. What's 6i times -1? Negative 6i. Is the I gone? No! Oh. Mormon. What are you doing with this? What definition did you write down? Very first thing.
Oh, subtract. Oh, you gotta take
3 minus 6i. Okay. Oop, got to be off my eraser. 3 minus 6i. Because there was a key phrase in that definition. I highlighted it in red. It said the product of 2 complex conjugates is always a real number. Always a real number. Which means if it's a real number, it's not a, starts with an I, imaginary number. So that gets rid of our i's. Okay? Now, if you do 3 minus 6i on the bottom, you got to do what on top? Same thing. 3 minus 6i. Now rewrite it as 1. Okay, so 2i times 3 minus 6i over 3 plus 6i times 3 minus 6i. Up top, we're going to do what starts with a D. Distribute Down below, 4-letter F word. Foil. Okay. So 2i times 3, 2i times negative 6i. So 2i times 3, 6i, minus 2 times 6, 12, I times I squared.
Please excuse interruption. We need the liturgical choir to record the same.
All right, now on. So down below we FOIL. So 3 times 3 gives you what? 9. All right, so let's see. That was that first. Now we go outside. That's going to be what? 3 times negative 6. Negative 18i. Okay. Now 6i times 3 is what? 18i. And then 6i times negative 6i. So positive times negative is going to give you negative 6 times 6 I squared. Okay. Now, there's a lot of mess to go clean up. Okay. You can do a couple things at one time if you want to. All right. If you want to clean up your I squares and combine your like terms down below at the same time, that's fine. Okay. I'm going to do step by step. Okay. So I'm going to go down here first. I'm going to do my I squares all at once. Okay. So 6i minus 12 times negative 1 all over 9 minus 18i plus 18i minus 36 times negative 1. Okay. Negative 12 times negative 1 gives you what? 12. Okay. So the top becomes 6i plus 12. The bottom, we get negative 36 times negative 1. It becomes what? 36. And what's the like term with 36? 9. So 36 plus 9 gives you? 45. What about negative 18i plus 18i? They cancel out. Look at that. Okay? The only way you're going to get rid of the I when you have a binomial here is if you multiply it by its conjugate. That's the key. That's what makes the problem work. Okay? Now, one more thing that is important. You need to catch on to it. What do you notice between 6, 12, and 45? By what? I think it's 3. Okay, it should be 3. All right. So you'd reduce all 3 of them by 3. Okay, so 6 divided by 3 gives you 2. 12 divided by 3 gives you 4. And Mr. Schmidt, what's 45 divided by 3?
15.
15. And that is your answer.